May 15th, 2026. These are the most important stories since yesterday. In energy, the world installed 112 gigawatts of grid-scale battery storage in 2025, roughly 10 times what was going in the ground just 4 years earlier. In medicine, Mayo Clinic researchers built DNA aptamers that selectively bind to the senescent cells driving age-related disease, with results confirmed in human tissue and live animal models. In science, a team reversed memory loss in aged mice by blocking blood-borne T cells that infiltrate the brain as the body ages. In infrastructure, the first production Tesla semi rolled off the Nevada assembly line, anchored by WattEV's $100 million order for 370 long-range Class 8 electric trucks running on 822 kilowatt-hour batteries. In AI, China's short-term drama industry is pushing out roughly 470 AI-generated miniseries every day. Script, voice, character animation, and scene composition all running on integrated model stacks. Also in AI, an Ontario audit of an AI clinical scribe used in primary care found the system adding prescriptions, diagnoses, and findings that had no basis in the recorded consultations. Deeper dives on all of this are in today's Century Report, and many are discussed further in today's podcast. Links to both are in the description. Or if you're already here for the podcast, let's get into it now. All right, let's start with a number. 112 gigawatts. That's the global installed base of grid-scale battery storage as of 2025, roughly 10 times the level just 4 years earlier. The same compounding curve solar walked in the early 2010s, hitting the same inflection points in the same order. Costs fall, use cases open, manufacturing scales, costs fall again. Lithium iron phosphate cells have dropped below the price where utility batteries outcompete new gas peaker plants in most markets. The ratio of batteries to solar in new project pipelines keeps tightening. Now, I want to really zoom in on what 112 gigawatts of batteries actually does to the grid. For most of electricity's history, supply and demand had to match instant by instant. Any storage that existed was expensive, geographically constrained, or both. A grid that can dispatch 112 gigawatts of batteries, with several multiples of that in approved pipelines, can absorb midday solar and release it across the evening peak. It can ride through frequency events. It can defer transmission upgrades. It can hold reserves for the kind of multi-hour shortfall that used to require a gas plant kept warm and idle for years on the chance it'd be needed for a single afternoon. Every one of those services was priced as a scarcity good, but they're now priced closer to commodities. And in the same news cycle, the second piece, the first production Tesla semi rolled off the Nevada assembly line. WattEV's $100 million order for 370 of these long-range Class 8 trucks anchors the first commercial fleet. The headline number is the 822 kilowatt-hour battery. That's large enough to put a fully loaded Class 8 truck on a 500-mile run between charges. Class 8 diesel trucks account for about a quarter of U.S. transportation emissions, while making up less than only 5% of the vehicle fleet. The economics of replacing them ran against the math of payload, range, and refueling time, but the semi closes that technical case on the first of those. The megawatt-class charging stations being commissioned along the West Coast freight corridor close the third. So trace this forward. For decades, the cheapest way to move a ton of goods across the country was to burn diesel, and every alternative was a moral choice that cost more. The semi is cheaper on a growing set of routes, numerous enough now to fill a 370 truck order. Every year the battery costs fall, the charging infrastructure densifies, and the diesel comparison gets worse. Inside the freight industry's own spreadsheets, the line has been crossed from concession to advantage. The drivers signing on with WattEV next year are moving the same goods on the same highways at a lower cost per mile than the rigs that they replace. If you pay an electricity bill, the generation mix supplying that bill is changing under load growth that nobody projected even a few years ago. Now, the full timeline of this arc, the battery prices crossing milestone after milestone, hyperscalers shifting procurement language toward 24/7 carbon-free energy backed by storage, all of it's on the ARCS tracker on the website. The grid emerging from this decade is going to be bigger, cleaner, and substantially more responsive than the one entering it. Storage stopped being the exception. The regulatory grammar built around that assumption is being rewritten around an asset class that didn't meaningfully exist just a few years ago. All right, shifting away, different domain, medicine. A team at Mayo Clinic published a paper describing a class of DNA aptamers. These are short, custom folded strands of synthetic DNA that bind selectively to senescent cells. These are the dysfunctional but still living cells that accumulate in tissue with age, and they refuse to die on schedule. They secrete inflammatory signals. They corrode neighboring tissue. They've been linked to a long list of age-driven conditions: osteoarthritis, Alzheimer's, frailty, fibrosis, several cancers. The field has known for years that clearing these cells in mice extends health span. What it hasn't had, though, is a reliable, non-destructive way to locate them inside the living tissue. The Mayo aptamers find them. The team reported selective binding in human tissue samples and in live mouse models, picking out senescent cells against a background of healthy ones at high specificity, and the chemistry compounds. The same aptamers can, in principle, be attached to imaging agents, to therapeutic payloads, or to fluorescent tags. The chemistry that locates the cells can be repurposed to image them, to kill them, or to deliver something to them on the way past. Senolytics, that's the class of drugs that clears senescent cells, has been stuck in a measurement problem for years now. The few candidates in human trials have shown signals of benefit, but neither patients nor regulators can see easily what the drugs are doing inside the body. A targeted aptamer that lights up senescent cells gives clinicians a readout. Dosing protocols become measurable. Trial endpoints become biological rather than symptomatic. The next generation of senolytics can be designed against a live biological signal instead of against guesswork. Now, I want to be careful, though, about what this paper actually does and doesn't do. The capability has been demonstrated. I keep saying this a lot. The capability has been demonstrated. Selective targeting in human tissue and animal models. What stands between that paper, then, and a clinic visit for you is still the deployment work, conjugating the aptamers to clinical-grade imaging agents, safety and dosing trials, signatory review. None of that is going to happen super quickly, but what the paper does do is move the date when treating the messiest category in medicine, aging itself, to something legible to instruments designed this year. It doesn't make it legible tomorrow, but soon, and the trajectory is now visible. A field that until recently was operating without an instrument now has one. And running alongside this, in the same news cycle, a separate team identified blood-borne T cells, specifically CD8 positive cells, migrating across the aged blood-brain barrier and contributing directly to cognitive decline in mice. When researchers used antibodies to block the T cells from crossing into brain tissue, the cognitive deficits in the old mice eased within weeks. Memory performance climbed back toward young control levels. Now, this is a new mechanism, parallel to the amyloid and tau pathways that have absorbed the bulk of dementia research funding for 3 decades now. The picture forming is a multi-system failure with multiple intervention points, some of them reachable through drug classes that already exist for other conditions. Now, if you or someone you love is in the age window where cognitive decline starts becoming a thing the family has to worry about, the research community working on this just acquired 2 new levers in 1 news cycle. Now, the translation work is still years, but the instruments are arriving, hopefully on time, to make a difference for you. Okay, shifting away again here. China's short drama industry. Roughly 470 AI-generated short drama miniseries are now being released each day across China's major streaming platforms. The format is vertical video serialized melodrama, 1 to 3 minutes per episode, sold by the episode through micropayments. The whole pipeline has restructured around integrated model stacks that handle script generation, voice synthesis, character animation, and scene composition from end to end. Production timelines that ran in weeks or months on traditional shoots now run in hours. Studios that built their identity around short drama production are either absorbing the pipeline change or being undercut by smaller teams operating with a fraction of the headcount. Now, as we've said many times, the labor disruption from this and from many other places that are impacted by AI, that is very real, and it's very concentrated to specific areas right now. Not for long, it will of course grow, but for now it's concentrated to, in this case, writers, voice actors, junior animators, post-production staff, a category of work that absorbed tens of thousands of practitioners over the last 5 years is collapsing toward a model where a small team operates a stack and the marginal episode costs almost nothing to produce. That contraction is showing up in working roles for a generation of creators who built careers on this exact format. And I don't want to dance around that. It's painful and it's happening at scale in many industries. But the deeper read on that is what's underneath the labor numbers. The architecture that the Chinese short drama industry ran on for the last 5 years was production pipeline orchestration as a captured advantage. Studios sat between writers, voice actors, junior animators, and the platforms. They paid below market wages because the supply of would-be creators exceeded the supply of studio slots. They captured the margin in between. 470 episodes a day is the moment here that that captured layer just dissolves. The model stack collapses the orchestration that the studio was selling. The same 2 or 3 people who can run script, voice, animation, and scene composition end to end can publish directly. The platform aggregation layer is next. Short drama is the canary, the leading indicator of a much broader compression. Every constraint that made this format the natural place for model stacks to land first, short episodes, low production values by film standards, audiences accustomed to rapid serialized output, revenue rewarding volume over polish, every one of these constraints softens in adjacent categories over the next several years. The infrastructure producing 470 episodes a day is the same infrastructure that will, in different configurations, produce educational content turned to individual learners, language tutoring localized to dialect and register, accessibility translation for media catalogs previously locked behind language barriers. The 2-person team producing a vertical video folktale by lunchtime is working with the same toolkit that will deliver a Mandarin grandmother in rural Sichuan a curriculum in the same specific dialect she speaks with her grandchildren. The studio system that gate-kept the short narrative format is dissolving into a substrate that any team with the story can use. Both of those things are true. The writers losing roles this year are absorbing a real cost. The marginal viewer requesting the kind of story they want and receiving it is a different person getting a new capability. Coverage that names only one side of the reporting is, of course, only half the picture, and this is happening everywhere. So, like I've said many times, this transition is not easy, but what we're looking for, if you look ahead to the future, is definitely advantageous. All right, last story. Same day, different layer. Ontario regulators published an audit of an AI clinical scribe deployed across primary care offices across the entire province. Ambient scribing, that's the category. The consultation is recorded, transcribed, and turned into a structured clinical note while the physician is still in the room with the patient. Where it works, it returns hours per day to clinicians who spent a decade losing time to electronic record keeping. The patients get more eye contact, and the note is more accurate than what a tired physician would type at the end of a 12-hour day. The administrative load that's been a leading driver of burnout for doctors gets absorbed by the model. What the Ontario audit found, though, is the seam in that process. Auditors compared a sample of generated notes against the original ambient recordings, and they identified discrepancies across multiple physicians and multiple visit types. Prescriptions in the notes that the doctor had never written, diagnoses that had never been discussed, clinical findings that contradicted what was actually said in the recorded dialogue. The audit findings have been shared with the vendor and with Ontario's health regulator. Deployment is being narrowed pending changes to the model's grounding and validation pipeline. So let's land this really carefully. The capability under audit is one of the more useful arrivals in primary care in decades. None of that goes away because of what Ontario found. What the audit identifies, though, is the seam in the system. This is part of the growing pains, right? The place where the generative model's tendency to complete plausible sounding patterns can introduce content that was never actually in the source. The systemic reading is that 2 forms of intelligence are being asked to share a high-stakes workflow before either side has really stable methods for verifying the other. Ontario's audit is the observational infrastructure that has to exist for the partnership to mature. It produces a calibrated picture of where the model's reliability tails off. And that lets developers retrain against the specific failure modes. It lets regulators set deployment scope. It lets clinicians know which parts of the note still need their eyes on it. The same shape of the audit is being assembled for radiology assistants, pathology assistants, autonomous coding collaborators, legal research collaborators, etc. Each domain is on a similar curve. Capability arrives, deployment outruns verification, an audit reveals the scene, the next deployment cycle absorbs what the audit showed. The next vendor releases into the first regulatory environment in which a methodology to test ambient AI in primary care already exists. The loop between capability release and audit response tightens from there. Ontario's regulator now has a methodology that it can rerun on the next version of this scribe and on the next vendor's offering after that. The institutional muscle for doing that work keeps strengthening with every iteration. The verification layer being built underneath the friction is one the practice of medicine did not have for most of its history. The workflow this scribe is replacing, the clinicians typing structured notes for roughly 2 hours out of every hour spent with patients, was itself the residue of the previous era of medical software, accepted as just a fixed cost of digital records for the last decade. But the audit forming around the scribe is the verification work that lets the older load dissolve at scale and correctly. Okay, so here's what today's evidence actually shows when we bring it all together. Storage cells multiplied tenfold in 4 years and started pricing flexibility as a commodity. A heavy freight truck rolled off a production line that the previous decade's freight economics could not price. Synthetic strands of DNA folded into a specific shape can now find the cells that age tissue. And a different team made an aged mouse remember things better by blocking the immune cells crossing into its brain. A creative pipeline that took weeks runs now in hours and produces 470 episodes per day. A regulator looked at AI-generated medical notes against the original recordings and named the discrepancies the moment they appeared. The thread under all of that is what happens when the capability and the infrastructure to verify it land in the same cycle. The aptamers identify senescent cells and make the next generation of senolytic drugs measurable, which makes them designable. The Tesla Semi ships into a charging station network commissioned alongside it. The Ontario audit catches fabricated prescriptions and produces a methodology that the next scribe deployment and the one after gets evaluated against. The Chinese model stack compresses production timelines and makes the marginal cost of an episode of moving image approach zero, which puts a different kind of media in reach of teams that the old pipeline never let through. And if you or someone you love is in the diagnostic window where aging starts becoming a medical conversation, the instruments arriving very soon are the ones that the next generations of treatment will be designed against. If you pay an electricity bill, the grid supplying it is becoming temporarily flexible at a scale that didn't exist a decade ago. If you've ever sat through a consultation watching the physician simply type instead of actually listening to you, the workflow that took those hours is being absorbed, and the audit infrastructure that lets that absorption be safe is being assembled at the same time. If you are a viewer somewhere on the planet whose dialect or language has never been served by a mainstream media production, the substrate that changes this is the same substrate, displacing the studio system that wouldn't make it before. What's becoming legible across all of this is that messy category: aging, freight, the grid, primary care, creative production. That's all becoming legible to instruments built this year. The instruments arrive faster than the institutions designed around the old constraints can adapt. And the audit, the standard, the payment program, the contract layer, the work of building the institutional response is being done by the people closest to the consequences, in public, on a clock that compounds for everyone who picks to work up. We'll see you tomorrow.